Okay, cool. Hi everyone. Thanks for joining us to the March session of the GDG. I hope everyone enjoys the session and maybe you'll learn a thing or two from our speakers. So what is GDG? GDG is the Google Developers Group for developers who are interested in Google technologies such as Android, Firebase, Angular, TensorFlow, Flutter, Go, Dart, etc., etc. So yeah, GDG Johannesburg, we meet every first Wednesday of the month, and you can find us on Twitter at GDG Johannesburg, Instagram, GDG Johannesburg as well, or drop us an email at gdgjohannesburg@gmail.com. So we've got a code of conduct, and by attending to this meeting, you agree to the code of conduct, which can be found on this link here. But basically, please just be nice and assume positive intent. But if you think someone is not living up to our code of conduct, you can drop us an email at gdgjohannesburg@gmail.com, or perhaps DM us on Twitter at gdgjohannesburg. So to make all this possible, we thank our sponsors, Lino, for the speaker's gift, Offers-in, JetBrains, and RetroRabbit for the streaming services. Yeah, and also please, for the meeting, try to join the Offers-in competition and then stand a chance to actually win some coursework from them. So if you want to be a speaker at our GDG, like the speakers we have today, you can get us in touch with us at gdgjohannesburg@gmail.com, or maybe drop us a DM on Twitter at gdgjohannesburg. Welcome everyone, new and experienced speakers. So yeah, please do that. Okay, so let Pamela talk to us about the upcoming event on the International Women's Day. Pam?
So I'd like to talk to you first a little bit about what is this Women Tech Makers, or WTM. Well, it's basically a program that provides visibility, community, and resources for women in technology. And you can join the program at womentechmakers.com. But we have a next slide, Vusi, please. We have this amazing Women Tech Makers event coming up soon. It's International Women's Day. Southern Africa will be joining with, it will be a South African event together with Zimbabwe and Botswana, where we are inviting all women, non-binary folk, and also male allies to join us in celebrating International Women's Day. It will be on Saturday, the 27th of March from 10 o'clock to 4 p.m. and it's online and it's free. You can RSVP on our normal site, just where you RSVP'd for this event, but it's bit.ly Women Tech Makers, or WTM IWD ZA 2021. And the theme of the conference is courage to create apps while there's COVID, courage to look after our families with great income from tech, courage to stay in tech. Next slide, Vusi. So our amazing Googler keynoter is Irina Shikman, and she's going to be talking to us about how to be productive while being stressed. She's a tech lead and engineer on the Stadia team. Then we have some workshops. The first one is about public speaking by a professional actress and director, and it's called Own Your Space, Overcoming Mental Barriers to Public Speaking. So if you've ever been stressed about going into public speaking and you need some ways to kind of mentally prepare yourself, this is the workshop for you. And remember, it's for women, non-binary folk, and also male allies. Everyone is welcome. Then we have an illustrator, Lauren Nell, telling us how to paint with coffee and ink during our lunchtime. So you don't actually need any artistic implements, you basically paint with coffee and ink, and it's really, really, really cool. I've done this workshop before. Then Sarah Scott from Over will be talking to us about social media and marketing for individuals and entrepreneurs. And that is going to basically help you promote yourself, promote your brand, and also your business if you have a small business. We also have 2 technical workshops. The one is on Jetpack Compose. If you're an Android developer, it's a very hot topic right now. And then also an introduction to AI design and development with TensorFlow by Tlamelo Makiti. She is from, I think it was, Botswana. So she'll be joining us from Botswana. Then we have this amazing women in tech, experienced women in tech panel. Look how super, super colorful it is. And I am so excited about this one. We have Lebogang Modise, who is a developer relations PMM from Microsoft. We have Rebecca Franks, who joined us in the audience just now. She's the Android lead at Over and also acquired by GoDaddy, and she's also an Android GDE or Google Developer Expert. Then we have Jacqueline Fischer. She's the head of UX at Superbalist. Tumi Seneko, who is the head of OfferZen Foundation. Debbie Rogers, who's the managing director of PrayCult.org. And Vinubashwa Nahira. And of course, Epic. There is an Epic. Next slide. Goodie bag. There's a goodie bag. Okay, there's a goodie bag. There's a goodie bag sponsored by Over and so on. So that's it from me. And we can continue with the rest of the program. Thank you. Hope to see you there.
Thank you, Pamela, for that. I actually can't wait for the event. So, yeah, let's get started to today's agenda. So first, we have Vusi, who will be talking to us about building microservices in ktor across the Hashicorp stack, and then we'll be followed by Marianne, who will be talking about web development with Kotlin JS, and then finally, we have Danielle, who will be talking to us about the D-KMP Architecture. So yeah, but please, throughout the session, feel free to engage with us on Twitter at GDG Johannesburg using the hashtag GDGJHB. So we'll see. Let's get started.
Okay, welcome guys. So let me just quickly share my slides. Okay. Hey guys, so microservices in ktor, the Hashicorp stack, and Fabio. So I don't know how many of you guys have heard of any of what I'm going to talk about tonight, but hopefully you'll find it quite insightful. And if you guys have any questions, you can let me know in the chat. So what's in this talk anyway? So what we're going to do is go over a brief overview of exactly what ktor is. We're going to work with two ktor services, user management, and the London Underground API. I had to switch that. You'll see how and why, which that's actually a bit more interesting. Basically, how we can push ktor Docker images to GCR, that's Google Container Registry, and then running both ktor images in something called Nomad. That's part of the Hashicorp stack I'll go into a bit later. Registering the service in console, again a bit later, also part of the Hashicorp stack, and testing reachability and communication between services. Okay, so Who am I? So I'm Vusi, as Patani introduced me as. I'm an Android engineer at DBT. I'm actually a co-organizer at GDG as well. I love Hashicorp products, as you'll see in this talk. A lot of the stuff is open source, which makes it really great to work with as well. Um, it also taught me how to do to actually not take microservices lightly, as you'll see. Twitter-wise, you can reach me at my handle at the bottom. Okay. So ktor, what exactly is ktor? So ktor is a web server framework provided by the guys from JetBrains. It is a very, very modular piece of software in that basically, you swap out the different types of libraries you need depending on what you're working on, right? So if you want authentication, you put in the dedication library. If you want to work with specific client-based things, so in this, like for example, if you're calling an external web service from your server, you bring those client libraries. If you don't need them, you leave them out. So extremely modular. That results in it being extremely lightweight. Because of the modularity in nature, because not all libraries are just given in one fat sort of library, it's really, really lightweight in that you in that you basically use only what you need at the time. Obviously 100% Kotlin, it's built from the ground up using Kotlin, which makes it really, really awesome. It also means that it was built from the ground up to support Kotlin coroutines. So you'll see that not just the code itself supports coroutines, but a lot of the server items as well. So basically, the server framework I use, Kotlin CIO, sorry, coroutine CIO, that's just exclusively coroutines, and then yeah, it also supports Kotlin MultiPlatform for the guys that are really interested in that. So our web server. So basically, we've got basically two services that I'm going to show you guys. This is basically the user API that we use. So the way ktor works in that we build everything using extension functions. So if you guys have used Kotlin before, we use a lot of extension functions in this. Like literally, all your routing endpoints are extension functions. Basically, the application module itself is an extension function, right? And basic. So if I show you here, what we do, because of the modularity nature that I spoke to you guys about, we basically need to install each feature as you go along. So if you want default headers, we install the headers. If you want to log out our particular API calls, we log that. If we want to use authentication, we log that as well. A really nice thing about it is the fact that you can basically define authentication based on different endpoints that you want. So let's say you've got, say here we've got like service auth, if you see here. So basically, because we're writing microservices, what I've done here is I basically have the different services using authentication between themselves. So a service auth token will not work with a user token, for example. And then the user auth token as well is what I use basically to authenticate users and exactly how that works. At the bottom here, we've got routing. So if you guys know how basically the essence of any web service ever is that we need to route our requests via specific things. So what we do here is we install the routing specific feature, and we tell we tell ktor exactly what APIs we want to use our routing with. So that'll be the user API, because this is our user service, and service API. So as you can see here, if I go to the user API, you'll see that it's literally just an extension function of the routing framework. Okay, and then at the bottom here, it also supports things like rate limiting. We basically it's just a way of us limiting our requests, so we don't have a lot of spam requests as well. Content negotiation, here I use JSON. For you Android developers out there, this will be very, very familiar to you. So it's a way to serialize and deserialize a lot of our JSON requests. We also use Firebase in this user service. So you see here, what I do is I actually initialize Firebase, and I use Firebase to basically verify that a user exists in Firebase before we service any requests. That way we know whether if a user doesn't exist or not in our service. then we can either reject or continue with the request. Okay, so that's basically a short overview. And next thing is, so that's just a really, I know it was a very sort of in-depth, but not really look at ktor, but we'll see how, because I've only got 20 minutes, I want to get through as many things as possible and show you guys exactly how we can bring up microservices with services written with that framework in mind. So how are we going to retrieve data to and from our services? How exactly does all this flow work? So basically, we expect the user to log in using the mobile phone. They log on to the user service, as I've shown you. The user service will essentially return a token response. That's basically a JWT token. As I said earlier, we swapped out the London Underground API for a dummy receipt service that I was playing around with. Basically, so instead of retrieving things about trains, now we get information about receipts that we've saved on this receipt app that we have, generic receipt app that we have. So what happens is a token response is sent back by the user service, then we get our receipts from the user service, from the receipt service. Now, this is very interesting in that these two are going to communicate. So essentially what happens is, as I said here, what we do is when the user logs in, right, we need to verify that first of all, that the token is legit, that it's authentic and that the user actually exists. So we essentially verify that the JWT token, retrieved from the user service is legitimate, and we do that using an external service using auth-o. Then the next thing we do is that we verify that the user does indeed exist in our system by talking to the user service about it. Then basically this will then go to sorry about that. Yeah, so essentially this is what we do, and then we return data to the user. Once these two are done, the receipt service then returns data to the user from a MongoDB instance. Okay. So how are we going to get our services to speak to each other? So this is the crux of the matter, really. So we've got our two ktor services up and running. That's a receipt service API, and that's a user service API. Cool, extension functions also well and good, but we often hear this term microservice, and sometimes I feel like it's used a bit loosely, in that people actually need to figure out exactly how this works. So this is something called Console. So Console is an open source service mesh tool from Hashicorp. Service mesh basically meaning how do we get our services, how do we get a whole bunch of services, a group of services to speak to each other? And this is what Console facilitates. It helps find the services within so services within Console can basically find each other. It works across any sort of IT infrastructure. So we have an internal infrastructure, external. You've got a bunch of ktor services running in our Arch organization. You may have different cloud providers, Google Cloud, Amazon, etc. Console works across that. Your ktor services will be able to find each other regardless. If your ktor stuff is running on top of Kubernetes, it'll work there as well. And we no longer need to know about IP addresses. I know this sounds like a really solved solution because we've already got DNS to do that, but I will show you why this is a very, very important point. Okay. So service mesh in 5. So how this actually works is that traditionally we have an external service that goes to some internal application, which is a monolith service, which basically is either is a fat jar or some other thing, right? So it could be like one ktor application that's written with a whole bunch of functions that does. So instead of, for example, having the receipt service and the user service separate, they're together, right? And they're usually hidden behind maybe one IP. Okay. Now, instead of what we do here is that when we deploy these microservices, we now have the services split between each other. So as I showed you earlier, it would be a receipt service, or it would be a user service, etc. We split across them, and then we've got different IP addresses. Obviously, this now presents a problem because now we've got all these different services, and let's say there are 3 user services. We're going to have an issue of, okay, which one does the user hit first? What happens if service 1 just goes on, is flapping in the sense it goes on and offline all the time? Scaling also becomes the issue. You know what I mean? And then the third issue that we may have when you have one service split like that, or multiple services split like that, is the fact that now you could say, fine, we can solve it using a load balancer. This is already a solved solution, Vusi. What are you talking about? So yeah, we can have a load balancer, right? But the issue is now that we have an extra hop in our network to get to those ktor services. Secondly, um, now it represents a single point of failure in that if this load balancer goes down, then all our ktor services are down. Okay, so how do we solve this problem? Because as well as you can see in this slide as well, you can have multiple services as well. What happens if you have something looking like this, where you've got user service here and receipt service over here, and they need to talk to each other? How is this going to work? How does this one know that this one's down? And how does this one know that it's servicing a million other requests, X and vice versa? So now this becomes a big issue. And this is where we see that microservices are also bringing their own bit of headache as well, which also we need to solve. Luckily, we've got console for that. So yeah, what if we could have our services discover and talk to each other automatically? Okay, so basically this is what console would help us with, in the sense that our services now register themselves in console. You know, it could be like, so for example, we have our user service and we've got our receipt service, packed individually, distributed across maybe Google Cloud, deployed using GCR and all the other fancy tools. What we can do is that we can get ktor to register itself with a console instance, right? What that basically means is it says, hi, I'm a user service, and you can find me at this particular DNS name. So the point that I raised earlier about what happens if, like now we don't have to use IP addresses. Console essentially allocates DNS names to each service that registers itself. So now we no longer have the issue of load balancing or etc. because console will say, okay, user service 345, I'll give you user service 345.service.console. Okay, so basically console, what it'll do is it'll basically give you DNS names under service.console moniker. So all your services, whatever the service name is, will find itself under basically service name.service.console. And that will allow our separate ktor services to essentially be able to find each other. If the service goes down, the ktor service, then a console will basically automatically remove that from commission. And then the rest of the network knows basically not to route service requests there as well. Okay. We can see the scalability in that, for example, if we decide to run 10 instances of our service, that's perfectly fine. We can run 1,000 instances, we can run 10,000 instances, we can run 1,000,000 instances spread across multiple geographies. And something like console will be able to look at that and be able to give each one a reachability context in terms of service name, reachability, DNS name, is the things that service, how you want to split traffic across, etc. Okay, now the next tool that helps us achieve this sort of reachability of the services is that we actually want to do Docker containers, right? So what we can do with ktor is we can package all our containers into, basically package all our services into a Docker instance, right? And what we can do with that is we can deploy it into a container orchestration tool called Nomad. So Nomad and console are very, very tightly integrated with each other. So what you do with Nomad essentially is that you basically describe it. You basically describe the service, exactly where you want to run it, how many containers you want, which is what the count is, the restart attempts you want for the service. So let's say you want to say, for example, if I attempt to restart the service more than 3 times, you need to fail the service. Okay, so that way we know that there's something definitely wrong. You can see here with Docker, what we do is we then pull the image from GCR, and we basically describe, and then what we do with Nomad is that we basically tell it exactly what port to map our service to, because when we deploy our ktor instance, we then basically tell it what port we need, and Nomad will then do the magic. Okay. What happens now is when we deploy in Nomad, it then tells us that cool, if our Nomad deployment is successful, We then have our 10 containers that we basically wanted earlier over there. Now all 10 containers are deployed successfully. And basically what happens here is that Nomad will then register everything in console. So basically here. So Nomad will essentially show that cool, this is where that registered via Nomad comes from. We've got 10 instances, and these are some of the tags that we can use. So basically when you look at it via DNS, it will be called something like we're on tube.service.console. Okay. Or basically user service.service.console or receipt service.service.console. Basically what I explained earlier. Okay. Cool. And then how do we ensure that everything is reachable? Okay, so let's say we've taken this container thing a bit too far with Nomad, and console's doing its console magic of making everything reachable. How do we make sure that if we spin up 1,000,000 containers, all those 1,000,000 containers are reachable? Okay, so this was the third thing in my intro, which was basically ktor, Hashicorp stack, and Fabio. The last thing we need to talk about is Fabio. Okay, Fabio is a load balancer, but different from the conventional one that we did speak about earlier. I know everyone will be like, wait, you said load balancers are bad. Not all load balancers are bad. So Fabio works exclusively with console as well, in that it is absolutely zero configuration. So whatever you find in console will then be loaded into Fabio. Okay, so Fabio basically waits for console to tell it, okay, so I've got 1,000,000 instances of the receipt service or 1,000,000 instances of the London Underground service. This is all the information you need. Basically, Fabio will then take that, load it into the routing table, and then essentially make sure that those services are reachable. This alleviates a lot of stresses, namely, we don't care what port any of our ktor services run. We don't care what system any of our stuff runs. Fabio and Nomad and console, that entire software stack does everything for us. It finds a system with available resources. It then deploys that system, and it then whatever. We don't care what ports are. We just want our app to run, and we just want our app to be reachable, whether we have 1,000,000 instances of one. Fabio will then make sure that whatever service is very important, advertised as healthy, is then advertised to the outside world and is shown that it is reachable. Okay. The only thing we need to do with Fabio from a console perspective is make sure that we add a URL prefix to our services. I'll show you what that is. So remember this thing I showed you earlier of our service, which is now rated via Nomad. The URL prefix is basically something that tells us what path we need to go to for that particular service. Okay, so in this example, we know that if we want to access anything to do with the way around tube service, we know that we access it via API/v1/underground. We don't care what comes after underground. We assume that it's underground/x. Okay. As long as we know that we've registered our service in console with that particular prefix, then we can Fabio will make sure that it'll route all the traffic directly to that particular instance. Okay. What happens is now that when Fabio now advertises as a successfully deployed instance of something, you can see like here a whole bunch of IP addresses we don't care about, a whole bunch of ports we don't care about. We do know that what we need to look out for is make sure that all these are basically found under here, and this is the weight distribution across each service. Okay, so Fabio makes sure that each service advertising console, as long as it's healthy, again, I will iterate, because unhealthy services will not be advertised, which essentially means that if your service is not reachable or is not seen in Fabio, then we know that there is something wrong with the service itself. You can gracefully go have a look at that without assuming that any of the other stuff you worked with before is not working. Okay. Yeah. So, okay. Yeah, so I know this is a super lightning talk, and I do want to do an in-depth talk at some point, but there's a lot of stuff that I went through, and I do understand that, but I really just want to highlight that we can deploy ktor in basically over 1,000,000 containers and make sure that it's reachable. Yeah, so what have we seen? So with the ease of using ktor, we can get any number of services up and running relatively quickly using a console Fabio, Nomad Trio, right? We're also able to launch them at scale, you know, ensuring, and we can also, like, we make sure that whether we're using bare metal laptop, using your MacBook, or using servers from digital or whatever, GCR, whatever it is, as long as that operating system is running on basic is can run Docker, it can run console and Nomad. Okay. With the ease of deploying our ktor services on private repositories like GCR, we can deploy our services as containers really, really quickly. And also because ktor is running Kotlin, code sharing between application and servers and everything is between basically Android, has it been easier? Yeah, so I know this is a very, very super lightning talk. I know I glossed over a lot of some of these in-depth concepts. If anybody wants me to do like maybe a series of blog posts, I'm just trying to put everything together for that. But if you guys are interested in learning more, please let me know. This is a very, very cool piece of tech. ktor is absolutely amazing for something like this, in that you can actually get the services to speak to each other, and it's no longer microservices as this little abstract concept. We can actually put it into sort of good use, and we can do it at scale, which for me is, if I can't scale an application, then I don't know what I'm doing with it. You know, that's sort of my mantra when it comes to backend services. Yeah, so yeah, that's pretty much it. Again, I know I spoke really fast, but I hope you guys really enjoyed that. A brief look at microservices at scale using ktor, and yeah, thank you very much.
Okay, cool. Thanks so much, Vusi. That was really super interesting, man. So we currently do not have any questions for Vusi, but please feel free to pop a question throughout the session, and then maybe Vusi can answer at the end. And also remember to tweet us at GDG, Johannesburg with the hashtag GDGJHB. So thanks, Vusi. So next up we have Marianne. Her talk is web development with Kotlin JS. Yeah, please go ahead, Marianne.
All right, can you guys hear me? Right, my slides are sharing. Just, right, so hi everyone. My name is Marianne Inober, and thank you for joining in on the talk tonight. So I first want to thank Google Developers Group Johannesburg for arranging this meetup, give a shout out to the other speakers, and also thank the amazing sponsors. So my talk tonight is about using Kotlin for web development, and specifically how it can be used as an alternative language compared to coding pure vanilla JavaScript or even TypeScript. So let me first give you a bit of a background on who I am, how I started with my web development journey. So I'm the founder and also a developer for Baroncelli, which is a software company based here in Pretoria, and we specialize in front-end development. So in my earlier career, I worked on Android as a junior developer, but I've been delving into web development for the last few years. I've also started my master's degree in multimedia at the University of Pretoria this year. So you can connect with me on Slack's ZA Tech community, on LinkedIn, or on Twitter using @084 Marianne. Right, so my journey as a software developer started at university, where I was taught how to program C++ and Java, which is usually the languages most colleges and universities choose, since it's great for teaching the fundamentals of programming and creative use for students to explain core concepts. So this is mainly due to C++ and Java being object-oriented programming languages. For example, it's easier to implement and explain design patterns, different data structures and algorithms, and the concepts of inheritance and abstraction, etc. So it's not that other languages can't be used to explain these concepts, but languages like Java, C++, and C# already have most functionality built into the compilers, and they've also been around for a long time. So most textbooks use C++ or Java to explain these programming concepts and to illustrate coding examples to students. So how is this relevant to Kotlin and web development? Now, personally, coming from this kind of strict, formal computer science background of object orientation, front-end development seems like this crazy Alice in Wonderland universe where the laws of physics only apply if you want them to apply. Now, there are web standards, of course, which is developed by the World Wide Web Consortium, but they are only enforced on a browser level, where the compiler and the renderer is located. So how you get there is up to you. Now, what are these browser standards, or basically the end destination? So in the most basic form, you should use HTML for markup, CSS for styling, and ECMAScript like JavaScript for scripting. So personally, when I started learning JavaScript, it was really fun, since there's no strict rules and no segfaults compared to C++. But I quickly found I longed for the structure of those early university languages. It's almost like rebelling as a teenager against your teachers and parents, and then only to find out later that they actually made some sense. Now, this talk is not to convince browsers to change the standards to compile Kotlin or even replace JavaScript. Since JavaScript's loosely typed structure works perfectly for usability on the web, you don't want the web page to crash or show a compilation error on the screen. But this talk is rather to help you understand, as a developer, what programming options are available to still adhere to the browser standards and why I'm personally choosing Kotlin. Now, to simplify this, we can group all these programming options into 3 categories. So the first category is going native, the second is going typed, and the third one I'd like to call going home. So let me explain these. So firstly, native. Just to note, the native should not be confused with Kotlin native. I'm referring to native from a browser's point of view. So in web development, that would be coding pure HTML, CSS, and ECMAScript. It's what the browser's compiler needs to interpret a web page or an application. Since we're focusing on the scripting side, in our case, that native option would be something like JavaScript, and even adding a library like jQuery would still be considered native in this case. So the second category is going So with strict typing enabled, this means you can't pull your magician skills and multiply your string name by 10,000. And this also allows the back and front end to stay in sync. Languages have evolved the past few years, and more functionality has been added than just typing, like adding interfaces, map types, mixins, etc., which is sufficient and effective. So the third option is what I call going home. So home in the sense of where your heart is, or using the tools that are familiar to you. So this category exists due to languages either being chosen based on the current environment, like the company or ecosystem is already in a particular realm, or the developers are already accustomed to a particular programming language. And now you would like to develop web pages too. So you can think about it, instead of Googling how to code a web page, you'd rather search, can I create a web page with language X? So if there is a big enough demand for the user base, usually the creators of the language will build compilers or interpreters to allow this. So examples are Blazor using C#, TVM using Java, and then of course the Kotlin with Kotlin.js. So what also kind of falls into this category Am I back? I think I disconnected.
Hi folks, don't stress. We're going to be back in a second. Marianne is just disconnected and she's going to try and reconnect very soon. But in the meantime, Putsane is going to give us an interpretive dance of his love for Kotlin. Let's put Putsane on the stage and yeah, let's all give him a round of applause. Yes? Putsane, are you excited? Okay, no. She'll be back soon, guys.
Okay, cool. Unfortunately, we lost Marianne. So in the meantime, while we wait for her, we can go through some of the questions that were directed to Vusi. Vusi will join us now. Can you please turn on the video, Vusi, so that... So the first question for Vusi is from Trust. He was asking is there a way to configure Fabio's ping for healthy containers?
So not necessarily. So remember, Fabio is basically zero config, right? So what it'll do is it'll read the service information from console directly, and only when console advertises something as healthy will Fabio advertise it. You see, so there really is no need for Fabio to ping. It's more that console will continuously do service checks on the container itself, like every 2 seconds, for example. I wish I had time to go into it, but essentially what you can do is configure service checks for console to say every 2 seconds you can ping my container, or let's say a healthy endpoint to my API, like API/health. and then basically that allows it to sort of interrogate your container. And funny enough, with ktor, sorry, I'm dragging on, but I'm nearly done. With ktor, for some reason, you can only use the CIO, the ktor CIO server module to essentially do health checks with console. It doesn't work with Netty, and it doesn't work with the other one for some reason. But yeah, short answer is you don't need to, because console will just advertise the healthy service.
Cool. Thanks, Vusi.
Cool.
The second one is from, well, you did answer this one anyway, but I think maybe you can answer it verbally. It was from, oh no, the same question, sorry about that, yeah. Okay, thanks. Since like we're starting to get Marianne back on, so I think we can move on to the third talk. This by Danielle. He'll be talking to us about the D-KMP Architecture, Declarative UIs, and Kotlin MultiPlatform, and the MVI pattern. So we welcome Danielle. Can you please share your slides?
Yeah. Can you see me?
We can see you. We can see your slides.
Okay,
Good. Thanks.
Great. Thank you, everyone, for inviting me to this GDG Johannesburg meetup. So I'm going to talk about the D-KMP architecture, where D stand for Declarative UIs and KMP stand for Kotlin MultiPlatform. So it's a very special time for Declarative UIs, because last week there was the announcement by Google that Jetpack Compose, which is the new Android UI toolkit, is in beta, and very soon, probably within 6 months, is going to be in the stable version 1.0. So I think it's a very hot topic right now to know how to build up using declarative UIs, and especially with the Kotlin multi-platform. So we're going to talk about also the MVI pattern. So we believe that the MVI pattern is the best pattern to mix declarative UI and Kotlin multi-platform. So let's go on with the talk, and hopefully you'll understand more about it. Okay, so historically, typically, apps did not share, apps on different platforms did not share any code between them. So if a company wanted to build 3 apps, Android, iOS, and web, they would build 3 whole apps, and which means also 3 times bug. But hopefully now, with the new technology that is coming up now, this year especially, we can do something much better. And with the D-KMP architecture, which I'm going to talk in the next 45 minutes, we are able to share 85% of our business logic, thanks to Kotlin multi-platform. And we are able to have platform-specific code, which is just the UI code. And in terms of effort, of code effort, is, if roughly speaking, is even half than just building 3 whole apps if you want to target these 3 platforms. So let's go to see more in detail what the D-KMP architecture is about. So as you can also see from the diagram, there is the DUI layer and the business logic, which can be fully decoupled. And we only share the business logic, which is, by the way, the biggest part of the code, which is 85%. So it sounds like a very big number, but hopefully in the talk you'll understand that the reason why this 85% is such a high number. And by not sharing the UI, we have also a lot of flexibility. So we have the flexibility to target not just iOS or Android or web, but even any other UI toolkit of any other platform. And this is different compared to other frameworks like Flutter or React Native, because they have their own UI framework. So if you decide to build with these 2 frameworks, then you would be locked into using their UI toolkits. And instead, if you use Kotlin multi-platform, you have the flexibility to adapt your business logic, your shared code to any other platform. And this is a very important advantage. So let's go to see which are the three pillars of this D-KMP architecture we'll be talking about today. So as we said, declarative UIs, and now we have a declarative UI in Android, which is called Jetpack Compose, which is going to become 1.0 by the end of this year. And in iOS, we also have recently, since 2009, since 1.5 years, we have Swift UI, which has replaced the traditional UI kit in iOS. So the second pillar is the Kotlin MultiPlatform, which is a multi-platform technology which finally makes sense and works, which we believe it's really a step forward compared to what cross-platform or multi-platform used to be, namely Flutter or React Native or even C++. There are certain companies that a few years ago, started maybe 10 years ago, they started to build shared code using, for example, C++. So now we finally have a technology which is really the best you can have at the moment, because again, we will see this more in detail, but you will be able to target each platform specifically. And then the third pillar is the MVI pattern. So the MVI pattern is based on the unidirectional data flow and a single source of truth for the app state, and is not using, and we are going to show in our architecture that we are not using RX Java for this, but we are using Kotlin. So we're using the new components that Kotlin less than 1 year ago made available. Okay, so before I start the proper talk, I want to thank all the people who made a lot of research on this topic, MVI, Kotlin multi-platform, declarative UIs. And in this presentation, what I'm going to do is to connect the dots between all this knowledge that has been shared through webinars or articles. And so I'm connecting into this architecture, which I call D-KMP. So let's go into more details. So this is a picture, a very simplified picture to picture what app development has been in the past and what we really believe very surely is going to be in the future. And it's a future which is not that far away. It's a future which can already, start now in 2021. So you would be one of the early adopters if you start this year. But I'm pretty sure that next year there won't be any doubt that an architecture will be, especially of greenfield apps, would be structured like you see here in the future. So briefly speaking, one of the main characteristics of the future of apps, how I like to call it, is, of course, declarative UIs, which compared to the previous UI toolkits, are able to be fully decoupled from the view model, from the data. So if you think about Android development, traditional Android development as it is now, you know that whenever you make an XML layout and you define components, you always need to define an ID for all these components. And if you want to apply data to all these components, you need not just the data, but you need also an extra layer where you associate the data to the ID, and then which is able to couple to the XML layout components. So basically, between the UI layout and the view model, there is always this extra layer of code. And this happens both in Android and in iOS. So to be more precise, if you think about find view by ID, is what exactly you need, this layer of code to connect your data to the UI layout. And in the declarative UI layout, you don't have this at all. Actually, your components, they don't even have an IDs. And this already is a very, one of the first reasons why we are able to be, to have such a thin UI layer, because the UI layer is stateless and fully decoupled from the business logic. So one other characteristic of the future is that we'll be able to share anything which is not the UI basically. And I was mentioning earlier, it would be 85%. And this is something very different than it was to be, because when it was to be in the past, because we tend not to share anything apart from web services, clearly. And then one other aspect which is important to highlight is that by being able to share so much of the client, so basically we're able to share the whole business logic of the client. In this way, we are able to put a lot more logic in the client. Before, we tended to develop apps which were thin client because it was very expensive to move any logic to the client. Expensive because any logic that you would put on the client, you would have to replicate for each platform. So when using Kotlin multi-platform, or multi-platform in general, but in this particular case, Kotlin multi-platform, so you're able to write logic once, so you can put as much logic as you want. And putting logic in the client means also to improve the user experience a lot. So let's summarize. So in the past, we had UI layout and view model, which required a coupling middle layer. So in the future, we would have a UI layout and a view model, which would be fully decoupled. So in the past, we tend not to share any code. And in the future, we'll be able to share 85% of the code. So in the past, we had patterns like MVC, MVP, MVVM. In the future, we would have pattern like MVI with a single source of truth for the app state. And in the past, we tend to build apps as thin client because client-side logic was very expensive. But in the future, we'll be able to have a rich client as the client-side logic is inexpensive. So we can put lots of more logic on the client. And because this is what is the reality. So the more logic that you're able to put in the client, the better user experience you're able to provide. Just, as an example, having no logic at all in a client, it would mean to, for example, query a web service, get the data from the web service, and presenting the data to the app as it is. And this means that each interaction, you would need to wait for the data, and it's not such a great user experience. So if you put more logic in the client, you are able to be much more sophisticated, so that you don't just show anything that comes from the server, but you're able to process it, and you're able to compose in any way you want. So this is a very important equation. So the amount of logic in the client is really proportional to the better user experience. Okay, so one important assumption we need to make from the very beginning is that this D-KMP architecture is aimed to greenfield projects. So our architecture is not about gradually introducing declarative UIs and KMP to existing project, but is to provide a clean, solid, and future-proof architecture, which is making no compromises with the past. And very important also to highlight that this D-KMP is not a third-party library or a library, it's an architecture. So it is based on the official frameworks on Java Compose, Swift UI, Kotlin multi-platform. So there is nothing really extraneous or foreign or third party that needs to be involved to build apps using this architecture. And in terms of the different layers of the app, D-KMP is structured to have a very neat separation of concern. So if you analyze data, we have the web services that would provide raw data. Then we would have a data layer, which is the layer which processes and does all the caching. Then we would have the view model, which is the layer who's doing the formatting. And then we have the declarative UI, which is just visualizing all the data. So as you can already notice from here, so the app state, so the state of the app, is something which is shared also, which is part of the view model as well. So for this reason, the declarative UI is a stateless UI. And this is the reason why it's able to be so thin. So we can do all our formatting, all our processing in the shared Kotlin multi-platform. And what is left is really a very thin layer. Okay, so let's talk more in detail about this first pillar, which is the declarative UI. Let's give a little bit of a timeline. So declarative UIs became very popular on the web, and this was thanks to React.js, which is a framework that was created by Facebook in 2011 and was open source in 2013. Then on mobile, declarative UIs first, one of the first, probably the first experiments was with React Native, which was the mobile version of React. But definitely the most important experiment that has been so far is with Flutter. So Flutter is a framework written that you program in using the Dart language, which is by Google. And I think Flutter has been really this UI toolkit which show how declarative UIs made sense on mobile for the first time. And thanks to the success of Flutter, the main two mobile framework also decided to have their own declarative UIs. And so Google in May 2019 presented Jetpack Compose as experimental. And then in June 2019, Apple presented Swift UI as also the declarative UIs for iOS. One thing to notice is that when Google presented Jetpack Compose, it presented as experimental. And actually, in fact, we are now almost 2 years later, which is still beta. And then we're going to be 1.0 by the end of this year. But it's curious to notice that Apple presented from the blue this Swift UI as version 1.0. So it was really unexpected. And to be honest, what they called version 1.0 was not really mature. But luckily, the year later, in June 2020, they presented version 2.0, and now it's working very well, I would say. Finally, yeah. Briefly, some characteristic of declarative UIs. So they just describe how the UI looks like for the different app states, but they are stateless, so they don't manage the app state directly. And they're able to achieve very neat decoupling between the, thanks to declarative UI, we're able to have a very good decoupling from the view model, from the data, basically. Okay, let's now analyze what I was expressing earlier. So, as I said, in the imperative UI toolkit, you always have an extra layer of code that is needed to couple data to the UI component. And this is, in Android, is find view by ID. Even though recently in Android, we have view binding, which is trying to simplify and to eliminate and to make it more simple to eliminate lots of boilerplate code. But even if you use view binding in Android, you still have somehow to couple the data. You still need this extra layer to couple data to the layout. And similarly, in the UI kit in iOS, we also need to couple the code to the UI component. And in the declarative UIs, it's very different because we actually, as you can see, we actually don't have this extra layer code. So in the declarative UI, you have your own view model, the data, and you're able to apply each field, each element of your object, of your data object, directly on a component, on a UI component, without using an ID at all. This also, as I say, it's really, is very beneficial for removing a lot of boilerplate code, and also, it removes lots of bugs at the same time. Okay, so more in detail about the Jetpack Compose for Android. So as I said, it was announced in May 2019 at Google I/O, and it reached alpha last year in August, and last week was reached beta. And we know for sure, because the Compose team said that is going to reach version 1.0 during this year. So we don't know actually when. It might be August, it might be November. They don't even know. But they promise that it's going to be by the end of the year. So we are really, really near. But actually, already in the beta version, the Compose team announced that the beta version is API stable. So all the improvements that are going to be from now to the stable version, they're just going to be performance improvements. So there's not any blocker at all to start coding with Jetpack Compose. One interesting characteristic of Jetpack Compose is that it just requires Android 5, so API 2.21. So this means that you are able to use the recent version of Jetpack Compose, with the existing devices. So and you don't need to target any later API for that. So basically, any update is going to be backward compatible because Jetpack Compose is simply like a library that you define in Gradle. So it's a bit like AppCompat. You just need to, if you want to use the latest version, you just upgrade the version and you're able to use it straight away there. And this is not the same in iOS with SwiftUI, because SwiftUI is actually tied to the iOS framework. So this means that if you want to use the latest SwiftUI version, your iOS app needs to target the latest iOS framework version. So there's no backward compatibility. And let's talk about the web now. So Kotlin for the web has got very convenient wrappers for React. So this means that you are able to write your UI for the web using React components and without even the need to use JavaScript, but you can just use Kotlin. And this is very convenient, especially for people who are really into React and they like and they're familiar with React components. But it's probably even more interesting, even though we are just at the beginning. So it's just experimental at the moment. So experiments started just a few months ago. There would be Compose for Web, which is the web version of Jetpack Compose for Android. So we can expect that the API will be very similar, probably not identical, but very similar to Jetpack Compose. So if you think about, we have 85% of shared business logic, and then just 15% of the UI toolkits. So for Compose for Web, instead of 15% extra code, you would probably just have 5%, because most of this code would be the same as for Android. So basically, you would be able to build a web app almost for free, which is clearly a really good perspective for all developers. And in the future, we can expect that Compose for Web would be compiled to WebAssembly, that we believe is going to be the future for the web. So we expect that in the future, we will have two families for declarative UIs. So one family would be Jetpack Compose, we call it usually, which is by Google and JetBrains. And you would be able to build apps for Android, for desktop. Actually, it's already possible. Now there are previews for Compose for desktop that is able to target Linux, Windows, and macOS. So all basically desktop operating systems. And web, that we hope that is going to progress quickly, and we're going to have, hopefully by the end of the year, some good version that is possible to use. And we can expect also for Wear OS and Google TV. And then we will have we have already SwiftUI by Apple. And with this SwiftUI, you're able to already build up seamlessly for iOS, macOS, watchOS, and tvOS. Basically, the same component that you define in SwiftUI, it's up to the framework to render accordingly. If you are on the phone, it's gonna render in a certain way. If you are on your Mac, in another way. If you are on the phone, so, and with the same API, with the same components. So this is very interesting. So we can expect even Compose with Wear OS or Google TV is going to do something very similar to what it's already doing Apple with SwiftUI. Okay, so now let's show a video, which is a very short video. So last week, there was this very important event by Google where they announced the beta version of Jetpack Compose. And during this beta version, there were very interesting news. And yeah, I'll show you this video. I'm not sure the volume is very good, so probably you should turn up the volume if it's not too loud.
Jetpack Compose, sets us up for the next 10 years. And more than that, I think it's a flexible toolkit. And so it's not just for phones, but I think it's going to be for lots of form factors like watches, wearables, TV, auto, tablets, laptops. And so I think it's going to serve us well.
Yeah, so basically we have an official confirmation by Dave Burke, which is the Vice President of Android Engineering, that Compose is not just going to be for phones, but it's going to also be for wearables, TV, auto, and laptops. I mean, this is not very surprising, but it's the first time that we hear from some official source like this. So we can really be safe learning Jetpack Compose, thinking that it's going to be the UI toolkit for the next 10 years. And yeah, okay. So here I show very briefly some code of Jetpack Compose and Swift UI. You can see these are very similar, the concept of declarative UI, which are stateless. So as you can see, as I was mentioning also earlier, you don't see any IDs here, right? So what you see, okay, so I explain what it is, sorry, more in detail. So in Jetpack Compose, we have a component which is called row, which is the equivalent of a horizontal linear layout in the traditional Android UI. And then we have 3 text elements inside this layout. And similarly, in Swift UI, we have this other component, which is called hstack, which is exactly the same thing, the equivalent of row. And you also see you have 3 text elements inside. So you see these text elements, and not even the other linear layout elements, they don't have any IDs. So we are able to apply the data object, so in this case, it's the row object, directly on the element. And this is a really very important simplification, which is already eliminating lots of boilerplate code comparing to the traditional UI toolkits. Okay, so let's now talk about the second pillar, Kotlin MultiPlatform. And let's give some timeline as well. So Kotlin MultiPlatform started experimentally in November 2017. So we are talking about 3.5 years ago, basically. So at the beginning, just with JavaScript. And then there was added support for iOS in February 2018 with Kotlin 1.2.20. Then it became alpha in August 2020 with Kotlin 1.4. And then now, I think some of you already know that Kotlin now is going to have a new release every 6 months. So we're going to have Kotlin 1.5 in the second quarter of 2021 and Kotlin 1.6 in the fourth quarter. So we don't know exactly, when it's going to be beta or stable, but we expect at least it's going to be beta for sure by Kotlin 1.6, and who knows, maybe even stable, who knows. But what is important to say is that the stage of Kotlin MultiPlatform is already very very stable, I would say, in terms of API at least. So you can really start working with Kotlin MultiPlatform and you wouldn't have any blocker. So of course JetBrains is going to make improvements, and there's going to be a beta and a stable version, but most of these improvements, they're going to be mainly under the hood. So there's nothing really that stops you from starting working, using it, and to build your own apps. And in terms of Jetpack Compose and Swift UI, as we said, it reached beta last week, and Jetpack Compose is going to become 1.0 by the end of this year. And Swift UI is already 2.0, and in June, with the WWDC 2021, there's going to be the third version. Okay, so this is a very important thing. So we tend to use the word Kotlin MultiPlatform as if Kotlin MultiPlatform was different from Kotlin. But actually, the best thing to say is that Kotlin is multi-platform, because Kotlin now it's fully a multi-platform language. So Kotlin started as a JVM language, and we know that in 2017 Google announced it as a first-class language for Android, and then in 2019 actually it became, you know, the preferred language for Android. So definitely Kotlin started as a JVM language, but now is progressing. You know, any new feature that is added now to Kotlin is added across all platforms. So we cannot, you know, define Kotlin a JVM language anymore. It is definitely is a multi-platform language, and so it's able to compile to JVM and for Android or for server side, as we saw already a talk earlier on during this meetup. And is able to be, we can compile it to native if we want to target to iOS or macOS or Windows or Linux, or we are able to compile to JS if we want to target the web. And then there's going to be a fourth target, which is going to come possibly in 2022, which is going to be WebAssembly. Okay, so all the codes of the business logic that we write in Kotlin multi-platform, it's compiled to a library. And let's see which are the formats, the compilation formats for the different platforms. So in Android, our business logic is compiled as a jar file, which is a, you know, totally native format for the Android platform. In iOS, it's compiled as a Objective-C framework, which is also fully native. And then for the web is compiled as a JS library. And let's now compare the D-KMP framework architecture to Flutter and React Native. So as we already mentioned, the user interface we write natively, Jetpack Compose for Android and SwiftUI for iOS, while on Flutter and React Native, you would use their own native proprietary widgets. In terms of business logic, for D-KMP, you would use simply the Kotlin language, and for Flutter, the Dart language, and for React Native, the JavaScript language. And now, more interestingly, let's see how it runs. So we already saw earlier that so we have the UI that is native, because we build with native toolkits, Jetpack Compose and SwiftUI, and we have the business logic, which also has a native format. So in Android, the business logic is a jar library, and in iOS is an Objective-C framework, which is and in Flutter is not as native at all. So first of all, in Flutter we don't have native UIs, because the UI looks the same in Android and in iOS, and is based on the Skia graphic engine. And it's compiled for Android as an NDK app, and in iOS as an LLVM. And in React Native, yeah, we have native UI, that's true. But the business logic actually runs as JavaScript and is able to interface to the framework thanks to a C++ bridge. So if you compare all these three platforms, you can see very easily that in terms of nativeness, there is not really any comparison. What is the most native out of the three? But also in terms of bundle size. So using the D-KMP architecture, by far you would have the smallest bundle size at all. And so, I mean, you choose yourself what you like, but I have my own preference. So let's talk about Kotlin multi-platform acronyms, because sometimes people, they get confused because they see several acronyms and they don't understand what they refer to. So recently, JetBrains introduced a new acronym, which is KMM, which is basically Kotlin multi-platform for mobile, and is an acronym that you use to refer just to mobile, just to Android and iOS. And also in August, JetBrains released a very, very useful plugin, which is called KMM plugin for Android Studio. And thanks to this plugin, which is incredibly convenient, you are able to run iOS apps directly on Android Studio. So in this way, you barely need Xcode at all, because although you need Xcode installed for iOS, but Android Studio is just connecting through Xcode, and you just need it installed. You don't really, if you don't want, you don't need to actually even open Xcode at all, for running both Android and iOS apps. And D-KMP is a more general acronym to mean any Kotlin multi-platform, including desktop and web. Okay, in terms of JavaScript, there is something very interesting which is coming up hopefully by the end of this year, 2021, which is the new IR backend for Kotlin JavaScript. And this is going to bring a lot of improvement, especially on the bundle size. And it's going to be a very, very, very important milestone for KMP on the web. So we believe that when this new IR backend it's stable, it's going to make it very, very feasible to ship in production web apps written in Kotlin. So many would ask, so is this technology ready? And my answer is definitely ready for Android and iOS, in the sense that you can definitely start developing. If for shipping in production, probably it makes sense to wait maybe a few months more, sometime in the second half of 2021, I would say you would probably have not any real problem to ship up in productions. In terms of web, personally, I would be very interested in Compose for web. So my idea is that it makes sense to start, first of all, doing this 85% of business logic, then releasing, targeting Android and iOS UI. And then after you've done all that, you can start, hopefully at that time, there's going to be Compose for web, and then you just need to add this 15% or even less on top, and then you would have also the web app. And for the web, I would say, it makes sense probably to wait 2022, but you don't need to lose any of this time, because you would be busy in this time already building the rest of the app. Okay, let's now talk about the third pillar, which is the MVI pattern. So the MVI pattern is typically referred as the evolution of the MVVM pattern, which is the pattern which is the most common in Android, in current Android development. So it's based on a unidirectional data flow and on the app state, which is the single source of truth for the whole app. So unidirectional data flow, it means that, for example, if the view wants to make a change to the state, it cannot do it directly, but it needs to follow the loop, the unidirectional data flow. And, and then now we can see more in detail in the next slides. So the MVI pattern, as I said, is based on the single source of truth for the UI layer, which is the app state. And it consists on immutable data. So the app state needs to be immutable, because at any one time, the UI layer should be able to render the data into the UI layer. And the app state can only be modified by the view model. And following a unidirectional data flow. So let's make an example. So you would have an app, and from the UI, you would have a user that triggers an event, or intent, as you want to call it. And then the view model, through the state reducer, would change the app state, would make modification to the app state. And then the view will be able to apply the new app state. And now we have another video. So you can turn up the volume if it's too low.
The state management is one of the most important things for an application. And we felt from the beginning that it was important for Compose to work well with a variety of state management solutions. And so Compose doesn't, in particular, kind of make anything too difficult for existing solutions. The Android ecosystem has really been moving recently towards this direction of MVI, and the MVI pattern works really well with Compose.
Yeah, so from the words of the Compose team, so also Leland Richardson is mentioning that MVI is a particularly good pattern to work with JPEG Compose and to declarative UIs in general. So, okay. Yeah, so specifically in our architecture, the D-KMP, we have Stateflow that is enabling our MVI pattern. So Stateflow was released in May 2020 as part of Kotlin Coroutine 1.3.6. And so Stateflow is enabling a multi-platform MVI pattern, which is, typically, if you read the early MVI pattern articles on Android, you always see mentioned RxJava. So now, thanks to Stateflow, we are able to achieve a multi-platform MVI pattern as a multi-platform, so not using platform-specific components, but something which is actually part of the Kotlin language. And it's working wherever Kotlin is working, which is at the moment really everywhere. So there's no probably platform that Kotlin is not able to compile to. And in our D-KMP architecture, Stateflow is able to propagate the up state from the view model to the ULA. So you can see also from the diagram here, and you see also reported here Stateflow. So Stateflow is able to propagate this up state from the view model to the UI layer. And this is actually his role, his function. So he's an observer. You can define it as an observer as well. So let's see how the app state is organized. So in our app, of course, we tend to have many screens. So it makes sense that our app state is organized in substates where each substate is referring to a specific screen. So this gives a very good modular architecture and way of organizing our data in our app. So let's see how the view model is like. So the view model is actually a Kotlin class. And as you can see, is a class which has Stateflow as a property, which is, what makes everything happens, propagating the data to the UI. But as you can see, this Stateflow is a computed property and only has a getter and no setter. This is because one of the requirements of MVI pattern is that the app state should be immutable. So it should not be modifiable. So how do we modify the state? Yeah, we still can. So we use another components which we call state manager, and this state manager is got as a property the mutable Stateflow, which is actually the read-write version of Stateflow. And as you see, the getter is just getting the data from mutable Stateflow. You can see that both Stateflow and mutable Stateflow has the up state as its type, because this is what they are propagating. They are propagating the object, which is the up state. And also the state manager has a property, as the data repository, the repo as a property. So let's see in the detail these two elements, which are the events and the state reducers, how they are defined. So the events, we define them as extension functions of the view model. And the state reducers, we define as extension function of state manager. So it's as simple as that. So we define these two classes, view model and state manager, and the two elements that we have to deal with, they're just extension functions of these two models. So, but let's see more in detail so we understand even better. Okay, no, one question. So you might question why extension functions are not methods. So because methods, they need to be inside the same file. So extension functions, you are able to define in different files, So, and this is very handy for organizational purposes, because in our file system, in in the view model, we can define two folders, one events and one state reducers. And inside of each folder, we can create a file for each screen. So one for home, one for profile, one for settings. And we can group all the events, which, as we say, they are extension functions, so they could be split across different files. And in this way, it makes our apps architecture and organization very simple and very clean. Okay, so talking more in detail about the state reducer. So the role of the state reducer is to create the new state, and is able to do that by combining three different inputs. One is the user event parameters, one is the repository, and one is the current app state. So if with an example, we can understand better. So this is an app, even if it doesn't look like, but think about this is an app with a list and several items. And there is a user which is clicking on one item, let's say on the city, Berlin. So what's happening now in our app is that we are calling an event. And as we defined earlier, and as we said earlier, we define events as extension functions of the view model. And this is actually what it is. This select city, it's an event function, so it's an extend function of the view model. So looking inside of this function, you see that you have actually two state reducers. So what are state reducers? So we already introduced it. So state reducers are what are able to create a new state. So we can see that in this select city, we have two state reducers, which means that there's going to be 2 times is going to happen that the state of the app is changing. And the state changing also means, each state change triggers a new screen, a change also on the UI. So because actually, when we in this sample app, what we are doing is that we are clicking on an element and we want to load some data. But before loading some data and getting some data, we actually want to display a loading screen. And this is what this state reducer is doing, the set loading state reducer. So we just click and then we call this state reducer, which what is doing is just changing a flag, our is loading flag from false to true. And this triggers a change in our UI, which is displaying a simple loading screen. And then inside our event function, what we are doing is that we are triggering asynchronously. We just launch a coroutine, and asynchronously we are going to load the data from the repository, which is inside this set details data. And what we're doing in this case is that we are, once this state reducer is executed, what is doing is that is setting the new data to a new element and then is reverting the is loading flag so that we are not showing that loading screen anymore. Let's see more in detail, specifically how these set loading and set detail data are composed so we understand even better. So this set loading, what is doing is using the Kotlin copy function. So the Kotlin copy function is a function which you can use on data classes. And what it's doing is that is basically able to modify immutable data, which sounds absurd, but that's what it is. Because what it's doing under the hood, this copy, is that it's duplicating an object. And on the duplicated object is setting some new element. So in this case, we are just basically changing one property, the is loading property. So, and this is what is happening, just that in the set loading function. While in the set detail data function, we are also doing something more, something else. So we are also fetching, we are calling a function on our repository, on our repo, and then getting this data. So we get this data and then we modify the property where we want to set this data on the app state and then also the other setting. So let's recap what the state reducer is doing. So as we say, state reducer is a state manager extension function, and is, as we said earlier, is using 3 different inputs. So one is the user event parameter. So in our case, is the Berlin input from our item, and actually is also the parameter, the input parameter for this state reducer function itself. Then another input is the repository, which is actually coming from the state manager, because we said earlier that the repository is one property of the state manager, and the state reducer is an extension function of the state manager, so it has access to the repository object. And the third element input is the current app state. And here, for simplicity, what we are doing is we are creating a computed property, because our app state, what it is actually the value of our mutable state flow. But in order to write in a more simple way, we are creating this state computed property so that we are able to write state equal state.copy. Otherwise, we would have to write mutable state flow.value equal to mutable state flow.value.copy. So this is just for simplicity. We are creating the computed property, and the code looks much neater. And so by executing this copy function, we are able to create a new app state. Okay, so let's now mention about the data layer. So the data layer consists of a repository, the repo, which connects to different sources. And this could be of any kind. So you could think about any different kind of data of any kind. It could be web services, GraphQL, runtime objects, platform settings, real-time databases, anything. So the repo is our central, data bank somehow, which is organized, which is connecting and storing anything which is coming from the different sources. So it's also the component that is organizing the data caching of our app. And if you think about that, this data, this code here, it can just be written once and applied to any platform. Okay, so we can do anything we want, even more complex things, because we don't need to replicate anything. So we could think about the most sophisticated data caching mechanism with all this incredible logic, and there's nothing stopping us from doing that, because this is the only place where we have to write. We don't have to replicate across all different platforms. And so, the function of the data layer is to provide the data, as we saw already in the state reducer, is through function, is providing unformatted data to the state reducers, and then, which is the one who's also dealing with the formatting. And then I want to mention something else about GraphQL. So I believe GraphQL is a great fit for Kotlin multi-platform in general, for anything which is a server-side database data. So if you want to deal with server-side database data, it's very simple to use something like GraphSQL, because it's a very flexible protocol which allows you to it allows the client to fetch the data and to decide which are the data to fetch, rather than the web services deciding and defining for you which are the data. So this also goes perfectly in the direction of rich client, which I was mentioning at the beginning, which is the direction of providing a lot of freedom and power to the client, and at the same time also moving as much logic as possible, as many decisions as possible from the server towards the client. And so in this way, eventually the client, the server would just focus just on data provision and data availability, and it would be the client, so the client developer, who would easily, without any blocker, being able to test all different data combination as he wants. And for KMP, we already have a working client, which is a GraphQL Apollo client, which is probably the most famous GraphQL client anyway. So it's already available for KMP, even though it's experimental. And then this is the last slide of my talk. And this is like a summary of the libraries that you would use with the D-KMP architecture. So obviously, in this multi-platform, you would not be able to use platform-specific libraries anymore, even if it's not true totally, because some of these libraries that you see, multi-platform libraries, actually, they do use platform-specific libraries, but they just wrap it. For example, multi-platform settings is a multi-platform library for dealing with local settings, and what it's doing is just wrapping in each platform the native library that is doing that. So in Android, it's shared preferences, and in iOS is NS user defaults, and also ktor client, which is actually the most important client for KMP, which has been released, developed by JetBrains. What it's doing is that under the hood is wrapping the native HTTP client on Android and the native HTTP client for iOS. Then let's mention, okay, we already mentioned Stateflow, which is our observable. So we would use these instead of live data in Android or combine in iOS. And for serialization, we would use Kotlin serialization, which is also developed by JetBrains. For structured data, we wouldn't use Room or Core Data, but we would use SQL Delight, which is a library developed by Square. And for concurrency, we would use coroutines, which is, by the way, also what normal Android developments should use nowadays. Okay, so this was the last slide. And if you want to know more about this architecture, you can read my article, which I published a few weeks ago on Medium. You can type my name or the future of apps, D-KMP, you can easily find it. And if you have any questions, just drop me a message, direct message with Twitter. But also, if you have questions right now, feel free to answer, and I hope you will be able, feel free to ask, and I hope I will be able to answer you straight away. Okay, thank you. If there are any questions, I'm happy. Hello? No questions? Pamela? Hello?
Unfortunately, we had a problem with our StreamYard platform.
I can hear you.
Can you hear me? Okay.
Now I can. Yes, now I can. Hello?
Okay, yeah, we can hear you now. Yeah, our streaming platform went down a bit there. Yeah, sorry about that. Yeah, so I think, are we back on YouTube? Just checking a bit now, sorry for that.
I missed something. So did you listen to me until the end, or there was something happening?
Yeah, I mean, the platform, there's a problem with the streaming platform.
So, the problem. Okay.
Yeah. We lost you, I think, for the last 2 minutes or so.
Okay, I see.
Yeah.
Right.
Yeah.
Okay, no problem.
Yes.
So basically, no question probably, or.
I think
so
there's one question about how to learn Kotlin or how to shift from Java to Kotlin.
Okay.
Yeah.
So how to shift from Java to Kotlin? That's a good question. It's a question you can answer in many different ways, I think. But I think Android Studio has got some automated tools also that allows you to convert from Java to Kotlin, even though I haven't used them personally. And,
okay. Yeah, thanks so much. I think that's the only question we had before we went down. Yeah.
How long ago was you down like 5 minutes ago. When did the connection?
Yes, I think we lost you 5 minutes ago. Yeah.
5 minutes ago. Okay. Yeah.
Yes.
Right.
Yeah.
No problem. Yeah, I hope people, enjoyed and they learned something. Hopefully, even if they didn't have a chance to make questions. But yeah, no problem. Okay.
I think before we let you go, there's probably a question as well. Let's see.
Okay. Is there a sample repo with some code? Yeah. At the moment, I haven't published a repo, but I mean to publish it soon, I hope. But at the moment, no, because I'm working on some production code, commercial code, so I was not able to share exactly the project I'm working on at the moment. Yeah.
Okay. Thank you so much for the answer.
Yeah, thank you. Thank you, Pamela. Thank you, Marianne and Vusi.
Cool. Thank you so much.
Thank you.
Yeah. All right. I think we have lost most of the audience, unfortunately. So, yeah, this is going to have to be the end of today's session. Thanks for all the speakers who presented for us today, and then thanks for everyone who joined us. Yeah, so if you're still with us, please join us again in May, because the next event we're having is the May session, and then it'll be Android themed. We have one talk confirmed already, which is we using Kotlin flows on Android. Yes, and then from there, I think we can go ahead with our survey. Please fill the survey and then let us know how to improve our sessions for the future.